Yeah. So welcome back, guys. This is Madhav PVL, and today we are going to see the next concept, that is depth first search. So now, before going to that, we are going to just solve this example. So after solving this, we will just get a bit clarity about what we are going to learn now. And in this, along with this solving of this question, and I'm also going to show you the application of Sudoku. So how the Sudoku is being solved by using this depth first search. So now we are also going to see even all those things. So before that, as we had discussed it in the previous class, that breadth first search is just handling with help of queue. So but in this we are just going to use stack. So we all know what is meant by stack, right? So I will just draw it now. So basically now in this there is no requirement of using something like a level 1, level 2, but now we are just going to start with the stack implementation. So firstly like this, so we will just create a small stack. Stack is something which we can just say like LIFO, last in first out. So now we are going to insert S. So after inserting S, then we can just cancel the S. So after cancelling the S, we can just consider either A or either H. That's your wish, but don't get confused. We are just use it to the thing like we are just considering the left side, right? So we will just fix upon that because to avoid some other confusions. So now I will just cancel the S because it is last in. So last in will be the first output. So S has been removed out. 1 second. I will just copy this. Yeah. So S has been removed out, and now we are going to take another stack. So after removing S, the elements which were towards its side will be written here, right? So now we are going to write A and H. First we will write the A, and now we are going to write H. So if we just see here again the last in first out, so H will go outside first. So after H has been moved, we will take another stack. So after H has been moved, then we are going to cancel the H. So after cancelling H, we are going to write the elements which were towards its side. So IJ. Now we are going to write A, and then I, and then J. So now we had just written all these three things. Now again we will just implement this LIFO principle. So J will get out, and after J has been out, there is no such element like continuation to the J. So there is no element, right? So we will just do one thing, we will just do the backtracking. So what is meant by backtracking? So backtracking in the sense we will just move back towards the parent node. So the parent node of J is nothing but the H. So H is having another element, that is I. So after removing of the J, here we are having I. So we are theoretically correct and we are practically correct. So to just check whether our stack is perfect or not, we need to just do like this. So now we will just take another stack, and then if we just see here, we are going to write A, and then we are going to write I, and then if we just see, if we just apply the LIFO principle again, so I will go out, and again if we just cancel the I here, I is having an element K. So now we are going to write K. A and K. Again now we are going to use this LIFO principle, and we will just remove the K, and after removing the K, as usual there is no certain things, right? Now again we will just do this backtracking. So now we will just backtrack again. So from K we are going to I, Even I has been cancelled, so from I we will go to H. Even H has been cancelled, from H we will go to S. Even the S has been cancelled, so from then we will just get into the A. So from there again the same process, we will just take A here, and if we just cancel the A, then we need to just write the B and C, and if we just cancel the B, we need to write C, D, E, and it is following the same process as we had just discussed it here. So in this way we will just even write the thing there. So from that solving, we can just come to a conclusion like, so with the help of this depth first search, either we reach towards one of the side of the depth. So if a tree is containing two sides, like our previous example, so with the help of this depth first search, we will reach either any one of the depth of that particular side of the tree. So it is a backtracking technique for finding all the possible solutions using recursion. So it starts from root node and follows each path to its greatest depth and node before moving to the next path. So it uses LIFO queue. Actually it's not queue, it's a stack, sorry. And now if we just get into this algorithm, so if the initial state is goal state, then quit and return success. So if we are just if we are just trying to find this S here, then we can just return like success. And if it is not the goal state, then we need to just do one thing like, so we need to just generate a successor, like incrementing the value of that particular pointer. So it will just get into the next things, and if there is no more successors, then we can just return a signal as a failure. So if successors return, signal success. So otherwise continue in this particular loop. So success is nothing but if we reach the goal state, then we need to return the signal as a success. Otherwise we need to just continue this same loop. So this is an example which I have just completed one of the part towards the right side. So we can just see here. So now I am going to just show you a little bit about this Sudoku application. So if we just consider here in the Sudoku application, so basically we need to know what is meant by the Sudoku game, right? So here we can just say like these are some horizontal lines. 1 second, I will just use something dark. So these are horizontal lines. This is a line and this is a line, and in this even we can just see there are some boxes. So there are some boxes, right? So here the basic rule which we need to just satisfy is, even at the every line which we are just going to draw now, so every line which we can just see here should contain the numbers from 1 to 10. So it need to contain the numbers from 1 to 10 in this line, even in this line. So it should contain numbers from 1 to 10, and even it need to contain the numbers here also. So here also it need to just satisfy the 1 to 9, sorry, not 1 to 10. So here also it need to satisfy 1 to 10 numbers. So here also it need to satisfy 1 to 10 numbers, and then even the lines also should satisfy the 1 to 10 numbers. So to satisfy this application, we are just going to use this breadth first search. So now we are just considering this, we are just taking the position as 1 here. So if we just take the position as 1 here, then we are just going to consider this as 4. So depth first search is nothing but we are just going in deep towards the last node. So we are just coming from the last to first. So in this way we are just going to search a proper solution for this depth first search. But basically in the game of Sudoku, it doesn't have any chance for again removing the value and keeping another value, but here we are just doing this process internally. So we are just doing this process internally, but the final output which we are going to get will be written by the machine in that particular solution. So I think this made some sense. So solving this Sudoku puzzle is the main thing which we can just use with the help of this depth first search. So thank you for watching. Please subscribe to Works of to College.